session for the first session of the day. In this session, what we're going to do is we're going to talk about serverless technologies and how you could use those in particular use cases. The first half of the discussion, you could kind of consider myself as the opening act in some ways, is to talk about serverless technologies and microservices. We'll do an overview of AWS Lambda and how you use AWS Lambda in that architecture. API gateway to be able to very easily provision endpoints that your services could invoke, and DynamoDB, which is a NoSQL database that's a managed service that we're providing. And then we're going to turn it over to Mike Jensen, Director of Engineering for DNC, and he's going to go through some of the use cases that his team has used in order to leverage things like Lambda and DynamoDB. Before we dive into serverless technologies, just to talk a little bit about microservices and what microservices are. First off, microservices are really a suite of small services that are all running. They're self-contained so that they all have a single purpose to do, single purpose when they're executing. One service might be a complex algorithm, another one might be a simple algorithm, but they're self-contained services. Oftentimes, you want to architect them so that they're interacting with each other through lightweight mechanisms so that invoking the various services is seamless. But each of them have their own data store. They're each an atomic unit operating within the microservices architecture. Why a lot of customers running on AWS benefit from microservices really comes down to things like agility and delivering capability very, very quickly for their customers. Both the first time to market as well as future releases for individual services as they're running. So, just wanted to set the stage for microservices. Let's talk a little bit about serverless technologies and why those are important. Probably most folks in the room are familiar with virtualization and the concept of virtual machines. With EC2, it's very easy to spin up hundreds, thousands of virtual machines and run very, very complex workloads where it was very hard to do on premises before. But with a virtual machine, what happens is you're abstracting away the hardware and you're running the OS and the application on top of that OS. So the unit of measurement there is the actual virtual machine. With containers, another approach that many folks use, the unit of measurement becomes the application or a piece of the application if you have multiple containers deploying out. There it abstracts away the hardware and the OS, and as you're scaling and as you're deploying out the containers, that becomes the unit of measurement. With serverless technology, the unit of measurement becomes the event function or the actual business code that you're deploying. All you have to do is focus on that business logic, and the rest of the event handling will actually execute in order to execute that runtime environment. With AWS Lambda, what happens is you're able to build that code, and as that code is executing, the only thing that's charged within AWS is the execution time of that Lambda function. What that means is you're never paying for idle, and the unit of measurement for Lambda is very, very small, so it keeps costs very low. Anytime a new event happens within AWS, the infrastructure executes that Lambda function for you. That event might be things like data being uploaded to S3, new data getting uploaded to DynamoDB, or data put on a Kinesis stream. You could also invoke Lambda through synchronous execution, so through things like an API gateway. API gateway allows you to have a RESTful front end to your Lambda function in order to execute that logic. But at the end, it really makes it very easy to perform things like real-time processing, build scalable web backends, and really choreograph or glue systems together. So why is this important, or why are folks leveraging serverless technologies? The first off, as the name describes, you don't have to manage servers yourself. And what that means is you could have quicker time to market, and it's much, much easier to focus on the business functions or application and deploy that out quickly to AWS. Because the unit of measurement is the function, and anytime an event happens, that function is executed, it's very, very easy to continuously scale. That could be through RESTful interface calls and scaling based on the number of calls being called, or it could be a peak in real-time traffic on Kinesis or S3 data getting pushed out to a bucket. But because of the continuous scaling and the function only executing when it's needed, you never pay for that idle CPU or anything like that. So what that means is it's always being billed based on the execution or as the Lambda function is doing work. So the pricing model within Lambda is structured in this way. So when you're purchasing Lambda compute, it's actually within 100 millisecond increments. And for one 100 millisecond increment, it's 21 microcents. So very, very low cost to execute Lambda. In addition to that, there's a really generous free tier. You're able to have, under the free tier within AWS, have 1 million requests with over 400,000 gigabytes of compute every month on your account. And that's not something that expires within 12 months like some of the other free tier services. So very, very easy to get started and start leveraging Lambda. To actually deploy your code out to Lambda, the first thing that we like to talk to customers about is various languages that are supported. Natively within Lambda, we have support for JavaScript through Node.js, through Java, and through Python. But with Lambda, you could really bundle any library you want and deploy it out. So you don't have to run Lambda with any specific pre-built libraries. You could use all your custom libraries that you want. Those could be native libraries as well if you want to deploy that out as that business logic that goes out to the Lambda execution engine. To specify how much resources that you want that Lambda function to run with, there's a very simple knob that you can turn, and that's really how much memory you want that Lambda function to have. What happens is, proportional to the memory, the CPU and network scales with that knob. And very, very easy to start calling through either ARNs or through API Gateway and these other eventing mechanisms. And of course, like all the other AWS services, all the authentication and authorization happens through IAM, Identity and Access Management. So you can have very fine-grained control of exactly who could execute the Lambda functions and audit that through things like CloudTrail. To complement Lambda, where it's very easy to encapsulate your business logic and focus on that unit of code or business logic, we have a managed service called API Gateway. The AWS API Gateway is a managed service that makes it very, very easy to create, provision, and scale RESTful endpoints. Since it's a managed service, it does a lot of features for you, and you could do things like define a Swagger implementation as your endpoint to define the front end for your backend Lambda logic. Some additional features like a caching layer and nice integration with CloudWatch gives you the ability to optimize the endpoint as well as monitor the performance of that endpoint. Some of the additional features within the API Gateway include things like built-in authentication that you could turn on, as well as the ability for customers to extend and provide their own authentication and authorization for the API Gateway. That is actually done as a customer through a Lambda function that you could configure within the API Gateway. There's also powerful features like DDoS protection, throttling if you want to turn it on, depending on what backend resources you're executing, and provides a really unified method for a front end for various Lambda functions. So both API Gateway and Lambda are stateless. And what that means is there's no state preserved between executions within those two tiers of the architecture. Oftentimes, what customers do is use things like DynamoDB to be able to preserve state for their application. Some other options include Elasticsearch and doing things like leveraging RDS, our relational database service, through a VPC connection. But what we're going to focus on in this discussion is DynamoDB. What DynamoDB is a NoSQL database that's completely managed for you as a customer. It provides key value lookup, and we'll dive into what that looks like within the table definition. But the other really powerful thing with the technology is, or with the service, is that it provides very predictable single-digit millisecond latency for your requests. And that's regardless of the amount of requests you do, as well as the scale of data that you store within DynamoDB. And like the other AWS managed services, it's very easy to scale based on your demand, and you only pay for what you use within the service. This is a diagram that we like to show that really illustrates the predictable low latency performance leveraging DynamoDB. And what you can see here is the blue chart indicates the number of requests for a particular region over a period of time, and the average latency that the databases, that the managed service is having at that given point in time. And what you'll notice is as the load increases and decreases on DynamoDB, the latency stays flat, stays horizontal. Since DynamoDB is a managed NoSQL database running within the region for you, the service itself is handling things like durability and availability of the data for you. And the way it does that is when you interact through DynamoDB through the interface, it stores the data automatically for you within at least 3 availability zones within that region. And when you're reading the data, you have the option to specify things like I want to read either eventually consistent or strongly consistent reads in order for you to get the data out of the distributed service. Within DynamoDB, the schema definition, or I should say the table definition, since it's schemaless, is defined based on a key. So each item within DynamoDB has a key, and then within that key you could specify an optional sort key. And that's another way of further defining a unique item in your DynamoDB table. Within one key value, with one item, you might have a different set of attributes defined than another set of items that you get that you store within DynamoDB. So you don't have to predefine all the different attributes that you may want to store within the DynamoDB table. All you have to do at the table creation time is define either the key or the key and the sort key together, and the rest of the attributes could be defined as needed. You could also do things like store JSON documents within DynamoDB if you want to interact with a NoSQL database that's more document-oriented rather than key value lookup. Any of the attributes that you see for the item row, you could also define things like an index on that data to make it very easy to look up and retrieve that data out of the NoSQL database. So, with those 3 services together, we see some common use cases across our customers that we wanted to go over. The first really is related to data processing. Since Lambda captures your business logic in a code function that you upload into the service, that code could get executed based on various events. So one common use case is when data gets uploaded to S3, you could indicate to S3 that you want to execute a Lambda function whenever that happens. When that function executes, you could do things like resize an image to create a thumbnail and store that into another key value or a key space within S3. You could do other things like create indexes within DynamoDB if you're storing additional metadata about your S3 data within Dynamo. You could do things like index elements into Elasticsearch. Any custom processing that you want to do based on data getting uploaded to S3. You could also have things triggered off of DynamoDB streams or Kinesis as a data layer trigger. Another use case we see for Lambda is based on building a scalable backend. Since Lambda could be synchronously executed as well as asynchronously executed, we see folks leveraging services like IoT and mobile SDKs in order to call Lambda to perform that business function. That might be through an API gateway if you want to expose that service through a RESTful interface. But it also might be leveraging services like Cognito in order to get a temporary access key to be able to invoke that Lambda function directly using our SDKs. And then oftentimes, for the backend persistence layer, you'll notice DynamoDB illustrated there. So most people are familiar with leveraging S3, and S3 is a object storage that you could use to store objects within AWS. Within S3, what you could do is you could define static web hosting to be able to serve out HTML document or HTML pages, CSSs, JavaScript files, various static assets that don't change on top of your web tier. Because of that, it's really, really powerful to be able to complement that static hosting within S3 and leverage things like API Gateway and Lambda together to really build rich web applications without running any EC2 instances under the covers. And the way that works is the static content is still served out of S3, and then that content could actually be configured to call an API Gateway through a RESTful endpoint to be able to execute that dynamic business logic captured or encapsulated behind Lambda. And what that allows you to do is really build this scalable web tier very, very quickly and be able to run it without running individual servers and have to provision the servers yourself. So, check the time here. So, when Lambda was launched as general availability early in 2015, it had a few, it had things like Node.js, and it was a really powerful service. By re-event of 2015, we released some new features based on customer feedback, such as support for Python and scheduled events, and longer-running queries or execution code for your Lambda function. Since re-events, you'll notice many additional features that we released, such as the built-in Swagger import, one-click CORS setup. So CORS is a feature that allows you to call a RESTful endpoint when serving data from another source, such as S3. And a lot of additional features that allow you to really see the pace of innovation for Lambda, just like you'll notice for the other AWS services. So that was a quick overview of some of the serverless services that AWS provides. I'm very pleased to welcome Mike Jensen up to the stage here to go over what DNC is doing.
Hey everyone, thanks for joining us this morning. So yeah, I'm Mike. I am the Director of Engineering at the DNC. That means that about 75% of my job is engineering, and then another 25% occasionally I get to do some directoring type work. Before I begin, I'm going to talk about some use cases and some ways we've implemented Lambda and DynamoDB in applications, some pretty critical applications that we are running right now. But before I do that, I'm going to give a quick overview of what we do at the DNC and kind of how that differs from campaigns and some of the unique engineering challenges we face here. The main goal of the DNC is to get Democrats elected up and down the ballot. That's our #1 mission. This differs significantly from campaigns. Campaigns have kind of a laser focus on a single candidate, but a lot of our work is more, at the DNC, is more infrastructure building, or kind of building the services that help power those campaigns so that they can do kind of the direct voter contact work. On the engineering team and on the technology side, that has a number of interesting problems. This means that we have to meet campaigns at their level of expertise. So when we're dealing with a presidential campaign like the Hillary campaign or the Bernie campaign, they have a full engineering staff, and they're going to be making use of a lot of our internal API services and some of our external APIs as well. When we're dealing with your city commissioner or your local state senate campaign, they're not going to have an engineering team. They're going to have maybe 1 or 2 part-time volunteers. And we are going to have to build embeddable tools that consume our own APIs that make it really easy for them to drop into their WordPress sites, or we may build static sites for them, or really whatever it takes to help support these campaigns. So I just wanted to kind of harp on why we use AWS at the DNC, and I'm going to take a quick detour here. So I'm sure you all have heard a million times, and you probably use AWS a lot, and that's why you're here. But we use AWS at the DNC because of the secure nature of it, how stable it is, and how scalable it is. And the detour I want to make is, if you all have seen the news in the past week, the DNC got hacked by the Russians. It's just kind of part of our job is we're always kind of kind of an attack vector for some external groups. But 2 things to mention there is, one, most of our technology infrastructure is based on AWS, and that meant that part of our infrastructure was entirely secured through everything. The second point I want to make is that we shut down almost all of our internal systems to do a major overhaul on Friday, June 11th. The first news story that came out was on Tuesday, June 14th, which was 4 days after we shut down all of our internal systems. If you all are familiar with the 24-hour news cycle or the nonstop rate of political news, the reason why this didn't become a news story at, let's say, 5:01 on Friday was because everything was built in AWS and it remained stable through all of our internal outages. Kind of jumping back to why we use AWS and why we started using Lambda and DynamoDB for a lot of our services is that we really only get one chance at election day. A lot of media events, they only happen once, and we have to be ready to respond to them. And all of the services that we build for campaigns have to be available at all times. These are 2 graphs of actual traffic we've seen over the past few months. We maintain probably around 50 services. It goes up and down, and it's probably just going to keep going up as we get closer to the election for different campaigns. And we never know which one is going to get slammed with traffic. We have a lot of ways to expect traffic. If it's an election day, if it's end of quarter, if there was a major media event, we can scale up and prepare for that traffic. If 10 campaigns all of a sudden decide to use one of our matching services and send all of their supporters information on that, we can't really predict that at the right time. Or if a conservative commentator decides to drive all of their listeners to one of our services that is more dynamic in content, we can't really predict that either, and we just have to be prepared so that we're not going down with any levels of traffic that we're seeing. We do this to make sure that all of our applications are performative. We do a lot of work to make sure that no matter what traffic we get hit with, we are prepared. We do a lot of testing. We use Git flow tagging and Jenkins integration testing before we launch anything, and then we also have a series of load tests before we push even to our staging environment and then push to production. We use Terraform for all of our deployment setup. We put as much of our content, our static content, into S3. We use a lot of auto-scaling groups and load balancers. And with all of our newer applications, we split those out into microservices that Ben was talking about at the beginning. All of our newer applications have a microservice architecture so that we can scale up the part of the application that we need to. With the introduction of Lambda and DynamoDB, these have been great tools for individual parts of our applications to make them more secure and faster. And now I'm going to go into some of the use cases we've had with Lambda and DynamoDB. These are going to be higher level, kind of like systems diagrams and going into how we've extrapolated different parts out of these applications. But if you want more details, just see me after this talk. So this is talking about our voter registration application. So we built an application for voter registration in 2012. This was built by the Obama campaign more than 4 years ago. This has had more than 25 developers on it, and in politics, people in places change pretty quickly. So we have basically no developers who worked on the original application, even that we were able to contact to figure out what's going on. The old system that we had was very monolithic. It was pretty server intensive for one of the most important parts of the processing, which was voter registration. And voter registration data is the most important data that we can get. These are, if they are going to a service that we provide and are registering to vote, this means that they are direct voters that we can get, and if we can turn them out to the polls, we can win elections with these voters. What we do with voter registration is we upload it as quickly as possible to Van, which is another service that campaigns use. That's not managed by us, but that's managed externally. That's called the Voter Activation Network, and they use that for all of their contact work. We build the registration connecting pieces and make sure that data can be uploaded into Van as quickly as possible. So this was kind of our old infrastructure, very basic. We just kept building on top of the core system over and over and over again, and it was becoming a problem. So we split this out. We split this out into multiple services. And the one part for this talk that I'll talk about is where we added a Lambda function right in before we actually populate the data over to Van. The reason we did that was because this was one of the more server-intensive tasks. So we were able to take load off of our servers, and so that the main servers that are handling just general traffic or general voter registration information are completely fine, and that process is extrapolated out into that separate function. The other reason we used a Lambda function for this, and we actually used a queuing, we use SQS separately, is because no matter what, we want to capture this data, and we want to make this available to campaigns as soon as possible. So if you register to vote and you're able to early vote tomorrow, those campaigns want to know that they want to be able to contact you as soon as possible and help you turn out. So as a backup, for any of the services that go down, we use SQS, and we keep churning through the Lambda function over and over again until we can upload the data and confirm that everything's good. Yeah, that's just made a lot of the data, the important data that we want, a lot more secure, and that makes sure that we have access to it a lot quicker. The second thing I want to talk about, the second use case for Lambda, where we've adopted it, is in one of our opposition research setups. And opposition research is pretty important to us. If you find out the right information on a candidate, it can break their campaign. And a lot of these systems, our researchers are really great, but they have to do everything manually. They had to. They had to watch all these videos on YouTube manually. They had to pull data from websites manually. They had to upload all of this data manually and then transfer it over to a separate database manually. That's a lot of work, and they're not really doing their research work. Instead, they're just doing kind of like data entry work. So we overhauled this system, and made it look a lot more like this. Now, we have RSS triggered downloads. This is using Amazon's API gateway and a Lambda function to process data into S3. Separately, we built a scraper system, and we still allow user uploads for data that we can't acquire that way. But then we also are able to process the data and get it over into our larger research system more quickly. And that means that researchers aren't duplicating efforts, and that as soon as an event happens, that data is live and available to them in the separate system that we build out for them. Yeah, and one of the more important things is that nothing is missed. Because we now have all of these services pulling in data, we're not losing anything that could be critical. Now, working with Lambda has been pretty great, but we have run into a number of issues. And kind of the biggest one is the second point that I have there, which is the limited error reporting. Because there's no full debugger in Lambda, the best way to debug for us has been to run a lot of these Lambda scripts locally, but then if they fail as Lambda functions, then we have to write a series of print statements to figure out why they're failing, and then kind of just keep going back and forth, re-uploading the Lambda function. It becomes a trial, a guess and check kind of thing with debugging Lambda functions sometimes. This was a larger problem for us when we tried. Most of our applications are Rails applications, so our developers wanted to write these Lambda functions in Ruby. We attempted to write these Lambda functions in mruby and jruby and then have them compile to Python, or with mruby we used Python container for that, and jruby obviously Java. But when we ran into bugs with these Lambda functions, because of the limited error reporting and because Ruby was not natively supported, we really couldn't determine what was going on and why the functions were breaking. In the end, we ended up writing these all in Python, and everything has been working great since. But those are some of the downsides to kind of trying to go down the Ruby route right there. And we did run into some disk space issues. I think it's 512 megs on the instance that Lambda spins up. Some of the data we're processing is gigs of data, and we needed to store that temporarily in the temp directory. And because of those limits, we actually had to separately process those manually. We created a system for any fail jobs, so that could be recorded, and then we could process those separately. The next thing I'll talk about is donations and how we've used DynamoDB for this. And I just wanted to show this large screen because this is our donation form. It's very large, it's imposing. We have like 16 fields on our donation form, every one of which you have to fill out. And the reason you have to fill out all those forms is not because we want you to fill out those forms, well, we kind of do, but election law mandates that we collect every single bit of that information. So we have to request that information from every single donor, and if not electronically, then you have to fill out a piece of paper that says everything from your occupation and your employer and all that before you can give us any money. But contributions are very, very important to our operation. We are funded entirely through donations and entirely through people deciding they want to support democratic causes. That means that if we are putting barriers between you contributing to the DNC, we are losing money for our operations. So on the engineering team, we've done a lot of work to make filling out that form a lot easier and actually clicking the contribute button. And the big solution using DynamoDB has to pre-fill as much of the data as we can with hash ID values. And DynamoDB has been perfect for this. This is an example. If you've donated to the DNC once, we store the information that we can store. We're not going to store your credit card information. We really don't want to save that information anywhere. But we will store your first name, last name information in a separate secure system, and then we'll populate that data in future fundraising emails. This is an example of all my information, not my real information, filled out into our donation form. I now just have to fill out my credit card information, and it's taken away 14 of the fields that you may have had to fill out. So as I said, DynamoDB is really great for this. It's a key value store, and we can use hash IDs to quickly look up donor information and pre-fill that data. Because it's fast and gives us secure access to that data, one of the things we've looked at is every fraction of a second it takes for a donation page to load or for a person to fill out a form, we are losing money that can go to support democratic causes. So having information load quickly is one of our most important tasks. DynamoDB has been great for this. It's it's also, we've been able to adapt really easily to event-based traffic. For example, end of quarter, we receive a ton of donations. Major media events, we receive a ton of donations. It also, we can scale up without any downtime, even a fraction of a second of downtime. So we don't even have to a lot of things when we've scaled up, we've had to done quick transfers to different RDS instances or different tables. There is, like a few milliseconds where if we get a request, that request might fail. But with DynamoDB, we can just scale right up. We actually had an instance a few weeks ago where we saw that traffic was getting higher, and so in a matter of a few minutes, we were prepared for the influx of traffic for donations, which is great for our operations. So a few quick takeaways from this. AWS has been really great for the operational speed of campaigns. We have to respond very quickly to any campaign needs, and we have to get applications up and scale up whenever necessary. So campaigns are relying on us to do our work, and AWS has been great for this. Lambda and DynamoDB, we found some very specific use cases and started integrating these into a number of our legacy applications as we've been refactoring them. And we haven't kind of gone all in on just a complete serverless architecture for any of our applications yet. But what we have done is extrapolate specific functions, hence the name like Lambda functions, into specific operations and run those using Lambda. And this has been great for stability and scalability. The use cases that I talked about, one was voter registration, one was our opposition research, and the other was donations. These are some of our most critical, some of the most critical things that we do at the DNC, and we are using Lambda and DynamoDB to make sure that they happen. And finally, we are pretty excited about a lot of the future integrations we have underway right now. We're using DynamoDB for a voter protection service that we're building out, which is built with Kinesis to stream a lot of the data and track some of the incident reporting we get. And we have a few other applications that we're looking at using Lambda for, and we more than likely will. So, yep, that's everything from me. So, thank you all.
So appreciate everyone taking the time. What we'll do is we'll stay up here for a few minutes, be able to field any questions that folks have. But definitely appreciate everyone's taking time to learn a little bit about serverless technologies.